On any given night, stargazing is a serene experience. But on a February evening in 1994, the calm was shattered. An explosion equivalent to at least 10 times that of the Hiroshima bomb occurred over a largely vacant area of the Pacific Ocean. Fearing that a hostile nuclear explosion had taken place, the President of the United States was then informed of the situation. It was only after the initial scare that the military realized that the threat they were dealing with didn't come from a hostile nation. It came from an asteroid. Was this powerful near miss a once-in-a-lifetime event, or a warning of things to come?
That may be millions of years before the next time we get hit by an asteroid, but it may be tomorrow.
Is there a doomsday asteroid out there with our name on it? Possibly, yes. There are plenty of asteroids that are big enough to penetrate the Earth's atmosphere and to strike the Earth. And the larger the asteroid, the more devastating it can be.
Is it conceivable that a huge asteroid could collide with Earth and wipe out the entire human race? And what are the chances of this happening during our lifetime? If there were such an asteroid headed for our planet, what, if anything, could be done to save us? And what secrets is the government keeping from us about the presence of these enormous space rocks? Finding the solutions to these questions could make the difference between the survival of our species and extinction. The morning of June 30, 1908, began like any other day in the Siberian forest. But in the remote region near the Tunguska River, a visitor from outer space was about to change all that. An asteroid exploded in the upper atmosphere with the force of 1,000 Hiroshima bombs. The heat from the blast charred tens of thousands of evergreens across hundreds of square miles. For days afterward and for thousands of miles around, the sky remained bright with an eerie orange glow. As far away as Western Europe, people were able to read newspapers at night without a lamp. But because of the blast site's remote location, the cause of this strange phenomenon was not investigated until 20 years later. Only then did scientists realize how close we had come to disaster.
It was lucky for us that the Tunguska event in 1908 occurred over a remote region. If that small asteroid had entered the atmosphere above a densely populated area, for example New York City, then in fact the devastation would have been phenomenal. Almost everybody would have been killed within the city, and the area of damage would have stretched way out into the states of Connecticut and New Jersey.
The Tunguska blast of 1908 and the explosion over the Pacific in 1994 provide frightening glimpses into the danger that is lurking in our solar system. Some astronomers have even described our planet as being in the middle of a gigantic cosmic shooting gallery. But are we really sitting ducks? Or are asteroid impacts relatively rare? For many years, modern scientists dismissed the idea of there being any danger from outer space until they found evidence around the world that changed their minds.
Meteor Crater in northern Arizona is one of the best preserved impact structures on Earth. It was formed by a meteorite that struck about 50,000 years ago. The object that formed the crater was smaller than 100 yards across, but the hole that it made was more than a mile wide and 600 feet deep. That's taller than the Washington Monument. It's so large that 20 football games could be played simultaneously on the crater floor. And at the same time, 2 million spectators could be watching from the crater's sloping sides.
Considering the fact that the largest asteroid known to man is about 630 miles across, the rock that impacted Earth to form Meteor Crater was a mere pebble in comparison. Yet today, an impact like this in a heavily populated area would be devastating. That's why it's even more frightening to think about the kind of damage that could be caused by a large object impact. Is it possible that such a collision could wipe out the entire human race? Imagine an enormous space rock that's on a collision course with Earth, more than 6 miles wide. It weighs over 1,000 billion tons and travels at speeds in excess of 12 miles per second. This nightmare scenario became a reality some 65 million years ago, and our planet would never be the same again.
Gravity and magnetic surveys show us that the crater, Chicxulub crater, is approximately 120 miles across. That's about the size of Rhode Island. The impact that formed Chicxulub crater was truly catastrophic. The amount of energy released was the equivalent of 10,000 times the nuclear arsenal of humanity. That's all American and Russian bombs put together. At ground zero, that blew the whole atmosphere away. After the impact, a gigantic fireball wrapped around the globe. Billions of tons of molten and vaporized shattered rock were propelled skyward. At ground zero, the Earth shook so violently that it would have scored a 10 on the Richter scale. That's 1,000 times more energy than the biggest earthquake on record, and it certainly created havoc all around the Gulf of Mexico. The impact's blast ring devastated everything within hundreds of miles. Tsunami, tidal waves, moved out from ground zero and hit hard the coast of the Gulf of Mexico, Louisiana, Texas. As dramatic as the impact must have been, the long-term effects were devastating. When the rocks from the blast re-entered the atmosphere, they heated up the air so much that the temperature rose to 700, 800 degrees Fahrenheit. That was enough to start wildfires all across the globe. The water and air were poisoned by acid rain, mostly sulfuric acid from the vaporized rock. Once the fires stopped, then came the big chill as dust and soot blocked out the sun. Inland temperatures plummeted for several years. After all that, the infamous greenhouse effect kicked in to raise the air temperature by about 30 degrees Fahrenheit. And that's enough to wreak havoc over the entire planet.
What effect did all of this have on the plant and animal species? Scientists believe it destroyed a full 2/3 of all life on Earth, including those creatures at the top of the food chain, the dinosaurs. With this in mind, we have to wonder, if an impact like this were to happen again today, could the human race survive? Or are we just jumping to conclusions? Is the theory that an asteroid impact can cause mass extinction supported by the evidence? There's no doubt that the dinosaurs became extinct at about the same time the Chicxulub crater was formed. But was an impact really to blame?
We know that an asteroid or a comet hit the Earth 65 million years ago. This generated a tsunami that pounded the shores of North America and the Caribbean, and we can see the evidence of that in the rocks on shore. This unusual sandstone layer is what we call an event bed. It's part of the KT boundary, which represents the interval of time when the dinosaurs went extinct. In it, we found a lot of shark teeth, shell fragments, fossilized wood, but the most important thing we found is a high level of a very rare metal called iridium. Iridium is found in very low concentrations on the Earth's surface. However, there's much more of it in meteorites. So when you find a lot of iridium in the KT boundary, that means it was brought in by meteorites, that is, by an impact. A giant asteroid or comet must have hit the Earth, vaporized upon impact, and spread its debris all around the world. The results, of course, would have been catastrophic. When the impact theory was first proposed in the 1980s, there were some scientists who believed that since there is more iridium down deep inside the Earth, perhaps volcanoes had spewed the iridium into the atmosphere. However, there is much more evidence of an impact than simply iridium. For instance, in the KT boundary you find shocked quartz, which can only be created by the immense pressures generated by an impact. It's a little harder to disagree with the impact theory once you realize it happened more than once. In fact, scientists have recently discovered evidence of another major extinction 250 million years ago, in which 90% of all marine animals and 70% of all land vertebrates were exterminated. And although we haven't found the exact location of the crater yet, evidence of that impact is found worldwide.
Regardless of the iridium evidence, The identification of this massive crater in Mexico, the Chicxulub crater, is persuasive evidence for the impact theory. The age of that crater and the time at which the dinosaurs died out are indistinguishable. And the chance of that occurring just as a fluke is less than 1%, so it's clear that an impact did occur at the time at which the dinosaurs were killed.
Another point to consider is this. If the Chicxulub crater was not formed by the impact of a 6-mile-wide comet, then how did a layer of iridium spread itself around the globe at the exact same period of time?
Although some scientists like to discount the evidence of the iridium layer found in the geological strata at the KT boundary, in fact, it is found worldwide, and I think that is compelling evidence for the impact theory.
Could something else have wiped out the dinosaurs? Conceivably, but that's like dying of the flu after falling off the Empire State Building. The impact theory is much more plausible. At the time of impact, the volume of rock excavated from the crater would have been huge, 100,000 cubic miles or more. That's like displacing a whole mountain range worth of rock. We can conservatively estimate that about 1% of that rock would have blown clean of the Earth's atmosphere. Most of that rock would re-enter Earth's atmosphere over a period of hours or days. That's enough time for the Earth to rotate underneath it, so it would land on Earth as a ferocious meteor storm all over the globe.
Imagine what it would have been like if humans inhabited the Earth at the time of the Chicxulub impact. Even if you were living a half a world away, there would have been no way to escape the deadly fallout or global temperature changes. The vast majority of the world's population, even the entire human race, would have been wiped off the face of the Earth. So the question is, could an impact of this magnitude happen again? And if so, when? Is it possible that our solar system has a sort of timetable for these types of events? And what can that timetable tell us about the possibility of another global catastrophe? If astronomers and scientists are to be believed, it's very possible that a doomsday asteroid is whizzing through space toward our planet at this very moment. But what are the chances of one of these enormous space rocks impacting Earth in the near future, or even in our own lifetime?
Looking at the ages of the craters spread around the world, a bit of a peculiarity is found. They don't appear to be random in time, that is, there appear to be epochs in which there are intense bombardments. For example, we find many craters which are around about 65 million years old, another group at 35, and going further back in time at 95 million years. So there seems to be some sort of a periodicity, some sort of a regularity, and that's something we need to be able to explain.
It's an accepted fact that large celestial bodies in our solar system can affect the paths of smaller bodies, such as the asteroids. Jupiter is a perfect example of this. But Jupiter has a period around the Sun of just under 12 years. That doesn't match the observed period of catastrophes on the Earth, which is between 26 and 30 million years. Could there be something in the solar system that has an orbit of 30 million years? I think the answer is yes. My colleagues and I have a theory that the Sun is part of a binary star system. That is, there's a second star, a red dwarf star, that's orbiting the Sun. We call that star Nemesis. Some astronomers call it the Death Star. Nemesis comes close to the Sun only once every 30 million years. Most of the time, it's 6 trillion miles away. At that distance, a red dwarf star such as Nemesis is too dim to be seen by the unaided eye.
Nemesis is an old theory, the idea being that every 26 to 30 million years a companion star to the Sun comes by, bringing lots of comets with it, some of which will collide with the Earth. The problem with the Nemesis theory is that the orbit of the companion star would not be very stable, and there's also the point that the star should have been discovered by now. A better explanation is that the impacts are due to asteroids deflected from the inner part of the belt between Mars and Jupiter. Recent calculations have shown that this happens frequently enough that we could get impacts every 30 million years or so. Some people subscribe to a 30 million year cycle. I think we're just seeing the effect of random events. In that case, a catastrophic impact could equally well occur 100,000 years from now or next week.
If the threat of a doomsday asteroid is real, Then what, if anything, is the government doing to mitigate this threat? Could it be that the people in power have convinced themselves that we have nothing to fear? Astronomers recently identified the greatest threat to our planet since near-Earth object tracking began. In the year 2000, the International Astronomical Union issued an alert. In it, they identified an asteroid named 2000 SG-344 and warned that it had about a 1 in 500 chance of striking the Earth on September 21st of the year 2030. After NASA made the announcement that 2000 SG-344 was headed for Earth, there was a flurry of activity. Astronomers began to search sky survey data to see if the object had been picked up in earlier observations but not recognized. According to the space agency, this turned out to be the case, and these past observations allowed a more accurate calculation of the asteroid's orbit to be made.
Initially, it was believed that an asteroid named 2000 SG-344 could come back to hit the Earth in the year 2030. However, we now know for sure that it will miss the Earth in that year by about 12 times the distance to the Moon, about 3 million miles. On the other hand, following its orbit even further forward in time, it's now found to be possible that it could come back to hit us in the year 2071. That's still a long way away, but nevertheless, we'll definitely be keeping tabs on it.
One day after NASA proclaimed the huge asteroid was on a collision course with Earth, they retracted their statement, which seems a little odd considering all the calculations that must have gone into making the original prediction. Could it be that powerful people in government demanded that the story be changed?
It's called a trial balloon. The government takes a story, salts it with just enough facts and truth to make it credible, and then they float it to the media. The public interest jumps on it. That's one thing. And if it doesn't, then they'll either retract it, or kill it, or just simply stonewall it. When the Doomsday Asteroid story broke, NASA moved at light speed to put a lid on it. Sure, there could have been a panic even though it's supposed to happen in 30 years, but I think really what was moving them so quickly was that it would have put the spotlight on them. And I don't think they're prepared to answer those questions yet. Beyond the embarrassing questions that the government is sure to face comes the prospect of global economic catastrophe. We've got a paper economy. If people are in a panic, they stop working, things dry up. We could have a depression that could make 1929 look like a cakewalk.
Did the government and astronomers lie to us about 2000 SG-344? Is this so-called doomsday asteroid still spinning out of control toward our planet? And will it be here in less than 30 years? Astronomers tell us that if a large asteroid were to impact the Earth, another mass extinction is not only probable, it's a near certainty. But how can we be sure? Has anyone ever witnessed a doomsday impact?
Human civilizations have been trying to predict celestial cycles for many thousands of years. The evidence for this is clear in megalithic monuments, for example, Stonehenge here in England. Or in Central America, the Mayan pyramids. Those also have a clear astronomical basis.
It's hard to say how much success the ancients had with these crude methods. But with the advanced technology we have today, can we be certain that we'll achieve better results? Is the government of the United States serious about finding the celestial objects that may threaten our very existence? And is it possible for astronomers to locate and track these objects? Or are we at the mercy of our solar system?
The first asteroid search program to use electronic detectors was the Spacewatch program at the University of Arizona. Starting about 20 years ago, they've been phenomenally successful. Previously, using photographic techniques, it was only possible to detect asteroids down to about half a mile in size. But Spacewatch have been able to spot lumps of rock maybe only 10 meters or 10 yards in size as they whiz by the Earth. In fact, over the last decade, Spacewatch has found several hundred Earth-crossing asteroids.
Impressive as the Spacewatch program's contributions have been, its achievements have been overshadowed recently by the activities of a government program nicknamed Linear. Run by the United States Air Force, the Linear program has revolutionized the search for doomsday asteroids.
Linear stands for Lincoln Near-Earth Asteroid Research Program. This technology was developed for the Air Force to track man-made objects in Earth orbit. Now we're using it to discover asteroids. The linear program is capable of detecting a 300-foot asteroid at 93 million miles. The rate of detection of near-Earth asteroids has dramatically increased in the last 10 years because the linear program was able to use classified government technology to aid in the search. In essence, linear uses super-fast imaging cameras attached to a telescope. It scans and photographs large areas of the sky every night. In the past, this technology had been used to track the 10,000 or so man-made objects circling the Earth, everything from spy satellites to lost astronaut gloves. It turns out it's just as effective at tracking wayward asteroids. At the rate they're going, the linear system will have everything in the inner solar system bigger than 500 feet identified in the next 5 years.
Yet with all this success, many astronomers contend that we'll never be able to find all the Earth-threatening asteroids and comets. Why? Because new ones enter our solar system every day from the mysterious far reaches of space.
There's a small but definite chance that there is indeed a doomsday asteroid destined to hit us sometime within the next century, perhaps. If that is the case, then clearly we need to find it well ahead of time, to give ourselves a chance to get out there and divert it, to make sure that it doesn't hit the Earth. The Earth has been hit many times in the past by asteroids and comets. We've got a long history. We can tell that from the craters, but maybe millions of years before the next time we get hit by an asteroid, but it may be tomorrow.
A lot of people think that the Earth's atmosphere can protect us from the threat of impacts, but that's only true for the smallest asteroids. There are plenty of asteroids that are big enough to penetrate the Earth's atmosphere and to strike the Earth, and the larger the asteroid, the more devastating it can be.
It was one of the most spectacular cosmic happenings that astronomers have ever witnessed. A comet discovered by noted astronomers Gene and Carolyn Shoemaker and David Levy in March of 1993 ran smack into the giant of our solar system, Jupiter. Dubbed Shoemaker-Levy 9, the comet was broken up into a number of large pieces by the force of Jupiter's gravity.
As the fragments of comet Shoemaker-Levy 9 slammed into Jupiter, we saw phenomenal explosions. Great dark spots were left like bruises across the face of Jupiter, and that grabbed a lot of people's attention when we saw that the areas of those bruises were 4 or 5 times the surface area of the Earth. We have to ask the question, what would have happened if it had been the Earth in the firing line?
In spite of astronomers' best efforts to locate and track all the Earth-threatening objects out there, many asteroids and comets will undoubtedly escape our detection. But perhaps even more disturbing is the lesson we learned from the impact of the Shoemaker-Levy 9 comet with Jupiter.
Put it simply, until we know what asteroids are like inside, we don't know how to deal with one that might threaten us. The only example we have of a huge cosmic collision is the impact of comet Shoemaker-Levy 9 with Jupiter in 1994. Each of those fragments hit Jupiter with an energy equal to 1 million megatons of TNT. To put that in perspective, that's like one Hiroshima bomb going off every second for a whole year. That's an extraordinary amount of energy for each of those fragments. And I think it drove home the point to the scientific community, and I think to the world at large, that the impact of an asteroid or a comet into the Earth's surface could be disastrous.
If we are confronted by a shattered comet similar to Shoemaker-Levy 9, we couldn't deal with it. We don't have enough information about asteroids or comets at this time because we are just starting to explore them. We've never tried to divert even one piece of space rock, let alone 21. So I think it's safe to say if the Earth were in the crosshairs of a shattered comet, it would definitely be a doomsday scenario. And that's got to change.
It would appear that the government is making an effort to find the asteroids and comets that threaten our planet. But is it enough? Will the linear telescopes detect every single object, or will some slip through? We will undoubtedly learn the answer to all these questions. Hopefully, it will be before the event takes place.